Okay, everybody, here we go. I'm out today, so sorry about that. And but it's all about your class, actually. I'm learning about the new materials we're going to pilot when we do the last unit this year, which is the surface area and volume. All right. Anyway, let's get on with this because I'm afraid this could actually be kind of long. All right. The warm up today is about what if we have these 9 letters and we're going to try to rearrange them. All right, first thing we need to kind of get out in the open is what are we going to do with vowels when there's a Y, because there's some controversy as to whether or not Y is a vowel. For this class, we're just going to go ahead and say Y is a vowel for all the questions when we have it. Otherwise, it's just going to be a problem as we move forward. So let's just make that decision and move on. Maybe your English teacher would disagree with me. I'm not sure. I don't want to get in that fight. That's not what math class is about. We just need to be clear so we can move on. So let's call Y a vowel. All right, if no letter can be repeated. All right, this is kind of like we're getting ready. I've talked before about how this unit is eventually going to get to the pre-calc stuff, and in the pre-calc stuff there's a lot of permutations, combinations, counting problems. All that stuff is based in the fundamental counting principles we did last time, which is about making these repeated decisions. If you have to have so many options for the first stage and so many options for the second stage, that you find the answer to the number of total possibilities by just multiplying things. The first question we had like that was things like the outfit that had to be like a jersey and pants and socks, and there were different number of choices for each thing. Or like the burger that was the first part of the homework for today. Anyway, so we're making a 5-letter arrangement out of these. How many choices do we have for the first letter? Well, we have 9, and if no letter can be repeated, then that whatever we choose for the first one is gone after that, and we have to continue taking things out and reducing by 1 the number of possibilities each time. This turns out to be this. Okay. If all the letters are vowels, then no letter can be repeated. Well, there is actually still 5 vowels if we consider Y to be a vowel. So, and no letter can be repeated, we're going to be left with 5 choices for the first, etc. That comes out to be 5 factorial, which is 120. If a random 5-letter arrangement is selected from the arrangements without repeats, okay, so right there, we're talking probability. I stop right here. I can figure out the denominator of that probability, and I've been saying all along that when you have probability questions, a lot of times it's helpful to think about the denominator first. So there's my denominator. My numerator is supposed to, so the thing I'm trying to find the probability of is starts with a consonant, 2, 3, 4, 5. Starts with a consonant, so there's 4 choices for that. Ends with a vowel, there's 5 choices for that. I can assign these in this order. Like I can think about the first and last thing first, and then think about the stuff that happens in the middle. That's going to be fine, because when I go to make this multiplication, the multiplication is going to be commutative anyway, so this is totally allowed. All right, so I've chosen the first letter, I've chosen the last letter, I've chosen 2 of the letters, and now I have to fill out the rest of this with no repeats. So I only have 7 choices left at this point. 6, 5. So if you look at this at the end and you see 4 times 7 times 6 times 5 times 5, it's hard to kind of realize like why are these things in this order? And it doesn't really kind of show up in the work that I actually did that first and then I did that thing second, right? Anyway, that's how it happened, and that's totally okay. Anyway, this turns out to be 4,200 out of this same denominator we start with. If you want to reduce that, it's totally fine. This happens a lot too, where they have these kind of counting questions first, and you get used to like, okay, how am I going to count up all these possibilities? And all of a sudden, at the end, out of the blue, they ask a probability question. You have to have a numerator and a denominator, so just be ready for that. They do that a lot. You'll see that in the warm up for the next lesson, also for 8-4. Okay, two-way frequency tables. This is a very common way to present information where there's kind of intersecting events, I guess. So here we have juniors and seniors, and for each of those categories we have whether or not they're going to the prom. What was nice here is that they set up this area in both these places where you can record what the totals are. If they don't do that, and that's going to happen later in these notes, sometimes they don't do that, you're going to want to have those totals, because those kinds of things, and in AP Stats we call this the marginal distribution. The marginal distribution is where we're going to find the denominators for a lot of our probability questions that we get to. All right, so the first thing is you got to fill this thing out, and if you're if you look at what the totals are supposed to be, it doesn't take long to figure out what these are supposed to be. So I'm kind of trusting you could figure this out. This is kind of a silly part of the question that's not really directly a probability skill. It's just subtraction and things. So the first question is, find the probability that a randomly selected student, okay, right there, I know that the denominator for all three of these things is going to be 160. As long as they're not saying, given that, right, like given that we have a junior, blah, blah, blah. If they're just saying randomly selected student, that means we're talking, this is out of the whole 160. So I'm gonna go ahead, like I said before, I think it's helpful to go ahead and think about the denominators first. And then that denominator helps you focus on what the numerator is supposed to be. So out of those 160, how many are seniors? That's just going to be 76. How many are not attending the prom? That's 59. And junior. Sorry, this is like saying junior and not attending the prom. Not attending the prom just in general is going to be 91. Now, this part C is slightly different. If a student was randomly selected from the seniors, okay, denominator now is going to be 76. So now just focusing on those 76, how many are attending the prom? We get 44. Okay. Hopefully life is good where you are. All right, the next thing, here's one of those tables where they don't give you what we call the marginal distribution in AP Stats. So they don't give you totals. You're going to want to have totals because the totals are, again, those things that might be denominators. Actually, sometimes they're even numerators, but anyway, they're very helpful to have. So I'm going to add those up, and I should be able to check those. Check those in more than one way, and that should make sense. If a person of the group is selected at random, okay, great. Denominator on all these is 389, so I totally needed that 389. Again, the only way that would change is if they said something like, given that the person does not smoke, blah, blah, blah. Or of the smokers, blah, blah, blah. Well, since they're not saying that in any of these, I know automatically all these denominators are 389. I'm talking and writing at the same time. So hopefully now all of these make sense. The trickiest one is probably this last one, smokes or gambles. Smokes or gambles is all of the gamblers and all of the smokers. So I have to count up all of those boxes. One way to do that is just simply add those three boxes. Another way you could do that, so you could say this is 152 plus 82 plus 97. Another way to do this is 389 minus 58. That's the only group that's not in that group. Or the way the book is going to say, or the way the resource is going to kind of say, this should be kind of coded. The way this is going to work in general is take all the smokers plus all the gamblers and subtract the overlap. Let me go back. Speaking of overlap, when we say smokes or gambles, do we include the people who do both? Yes, we include the people who do both. If you are a smoker and gambler, and I hope you're not a smoker and a gambler. I hope you're neither. Anyway, if you are someone who smokes or gambles, smokes and gambles, say if you're part of this 152, and someone comes up and asks you, hey, do you smoke or gamble? You're not going to say no. You're not going to say, no, excuse me, I smoke and gamble. So, no, you're not going to be that jerky about it. You're going to say, yes, right? If there's a smoker party, you're going. If there's a gambler party, you're going. You are in the smoker or gambler club if you do both. So we want to count that 152. Okay, so why did I subtract it here? I subtracted it here because if I add 234 plus 249, I would have counted that 152 twice, and I only want to count them once. Anyway, you'll realize that in all three of these ways to calculate that, you're going to come up with 331 no matter what. So they are all equivalent. This idea will come back, the idea of adding both of the sets and subtracting how they overlap. That's a general rule for addition for OR, and we will definitely touch on that again if that didn't make sense. All right, Venn diagrams. They gave this Venn diagram here that has Spanish and Mandarin and all the sections enumerated for you. I kind of like to add a little bit to my Venn diagrams and show here. Now, this is not required, but I think it's helpful. It's not, part of the definition of Venn diagram, although this is. People forget that. Let's get an idea of what the whole Spanish circle adds up to. So this whole circle for Spanish adds up to 161. This whole circle for Mandarin adds up to 215. I think that's helpful to have because, look at the first question. It's 161 out of. Oh, yeah, we didn't think about denominator first. So if a student is selected at random, right there, I know these are all going to be out of 366 unless I get a crazy given that. But I think these are all going to be 366. All right, he or she took Mandarin is 215. Right, because that includes the 37. Spanish and Mandarin, well, that's actually given to us. That was 37. Did not take Spanish. So did not take Spanish includes that group and that group. Everything outside the Spanish group is 178 plus 27. I get 205. And Spanish or Mandarin, again, is going to include all of those. That's Spanish or Mandarin. If you're part of the 37 and you speak both, you are going to say yes to this question. Do you speak Spanish or Mandarin? If you're both, you say yes. So all those I get adds up to 339. Okay, here's a little bit more about and or. These little symbols here and here are how we kind of notate and or in math terms. This symbol is actually also sometimes referred to as the intersection symbol. And if something is in A and B, you'll notice it has to be in that little kind of sliver that's in both parts. Where this one is the or, we think of that as the union. And if it's in A or B, notice we are counting the both. Oh, you can't see my red on red. We do count the both. You really can't see that. We do count the both part, that kind of middle part, in the or because, yeah, if you like in this previous example, if you spoke both languages or you took both classes and someone asked, hey, are you in Spanish or Mandarin? Then you would say yes. So we do count you in both. Okay, here's a funny thing. There's a couple places in this worksheet where the graphic was inserted and the line, it like broke the line of text, and it's kind of funny. This is not so bad as the next one. The next one's really funny. Anyway, that 10th is supposed to go over there. All right, so in 10th grade, there's 280 students. I like putting the max or the sample space size kind of up here. And then 200 take geometry, so I'm going to put the geometry 200 there, and the algebra 2, 66 as such, and then they tell me 45 are in both. And when they give it to me that way, yes, I know I can infer that it is implied that the 45 is part of both of those sets. So the 45 is part of the 66, and the 45 is part of the 200. Then I can figure out how many are left on the outside. That's the 280 minus all of this stuff. It tells me how many are in neither. And now I'm armed with enough information to be able to answer all these questions. So again, this is out of 280 because it's out of the whole group. If a student is selected at random, what's the probability of G and A? That's 45. G or A is 221. That's all these things added up. Oh, what's the probability that a randomly selected, this is part D, what's the probability that a randomly selected 10th grader is, that takes Algebra 2. Okay, what's the denominator now? If you take Algebra 2, you are in the club of 66. How many of those people also take geometry? Again, I think that's helpful to do the denominator first. It focuses our attention on kind of this new sample space, or where are we looking to find our numerator as a subset of, and it's out of that 66. Okay. Two-way frequency table. They didn't give us the totals. The totals are going to be really helpful. Let's put those in. This is out of 30, I believe, totally. Sorry, I'm trying to verify that. This is, if you add up these rows, it looks like this. If you add up the columns, it looks like this. Okay. What's the probability? So if you just take a random painting out of the whole thing, this is going to be out of 30 on all of these. What's the probability, because they didn't say given that, what's the probability it's a landscape? Landscapes are 11. Portraits, oil or portrait. This is probably the hardest one. Oil or portrait. It's all of those things. So you could add up those, what is that, 6 numbers? You could add those up and you'd figure out that it's 13. You could use that textbook thing, which says it's going to be 6 plus 10 minus 3. I don't know if you're ready to think about it that way yet. Or you could think, all right, I know it's all of the 6. It's all of the oil paintings, and it's all of the portraits. If I count up all, and this is really what that textbook explanation is, if I add up all the oils and all the portraits, I will have counted this 3 twice, so I need to subtract it once. Again, you can see the whole sample space here, so if you simply add up the 5 numbers like that, you'll see that it's definitely got to be 13. Okay, still life and acrylic. I see 3 in that cell. That's just this. That's a 3. Not watercolor. Well, the watercolor is 12 of those, so it's the rest that are not those 12, so it's 18. Or you could add up these 18 here. Probably the random portrait. Okay, we're talking about portraits now. How many portraits are there? There are 10 portraits. Of those, how many are watercolor? It's 5. This is a given that conditional probability. Here, if it's an acrylic, so if it's an acrylic, we're only talking about those 6. How many of those 6 are also still life? I see 3. Okay. Next thing. So the beauty of this video is you can pause it and you can do things slowly and repeat them. All right, let's talk about this thing. This thing tells me that the sample space is 100. It also tells me that there's 0 people left out. So I have used everything in that kind of bullet. 14 of the visitors have seen X and Y, and 3 of those 14 have also seen Z. So the best part about that is I know 3 has to go in here. X and Y, so this whole thing, they're also telling me has to add up to 14, which tells me this part has to be 11. That was a bit trickier. 36CX, so I'm going to go ahead and put this 36 here. The problem with that is I know something goes there and something goes there, and those two things add to 36, but I don't know how that spread goes yet. They could be both 18, they could be 30 and 6, I don't know. I just know that those two areas kind of add up to 36, so I'm going to come back to that. 55 like Y, so I know that's true, but that's all of this, and out of this there's only one unknown area, so I can subtract and figure that out. That's not so bad. Same thing with this. If this is 53, this whole area adds up to 53, and I know everything else about that, which lets me put a 6 here, and now I can get back to this 36, and I know that 36, whoa. Yeah, that 36 is this whole group here. So sorry, this group plus this group is going to have to add up to 22 to make the whole thing add up to, the whole circle add up to 36. All right, so that's actually 16. Now I'm done with this. Okay, what's the probability that a visitor selected at random? Okay, so that's out of 100. What's the probability that, and they ask about this one because this is the most interesting one of the whole day on that. Okay, that's it for this section. I'm going to stop here and make the other video be a part 2.